In this section, we're going to be looking at root mean squared and molecular speeds of gases. So root mean squared, abbreviated RMS, is the average molecular speed of a molecule with an average kinetic energy. And the formula is mu, okay, so that U with the tail on both sides is the way I call it, is the square root of 3 RT over molar mass. Now, up until now, R has been 0.021 or 0.06. However, this time, because of the fact that we're dealing with speed and not pressures, R is now 8.31. Okay, temperature still has to be in Kelvin. The other thing is that molar mass, which we have done up until now, as grams per mole, has to be in kilograms per mole. Okay, so this is a figure from the textbook, and it shows what the distribution of speeds are at two different temperatures. I have 0 degrees, and of course 0 degrees is cooler, so it's going to move slower, but there is a distribution. At 500 degrees, being warmer, the average speed is faster, but it's also a bigger distribution. Okay, so some molecules are going really, really slow, other molecules are going really, really fast, but the average speed is what we're going to be calculating here. So here's an example. It says for a spacecraft or a molecule to leave the moon, it must reach escape velocity of the moon, which is 2.37 kilometers per second. So I have an escaped velocity is 2.37 kilometers per second. It tells me that the average daytime temperature is 365 K. What is the RMS? In RMS, we abbreviate using mu, of a hydrogen molecule at this temperature, and how does it compare to escape velocity? Okay, so the formula for RMS is mu is equal to the square root of 3 RT over molar mass. So R is that 8.31. It's still a constant, it's just a different value. I have my T at 365, and the molar mass of hydrogen is 2.02, but this is in grams per mole. And the fact that it has to be kilograms, so there's 1,000 grams per 1 kilogram, means that it's going to be 0.00202 kilograms per mole. So now I'm ready to plug this in. Mu is equal to the square root of 3 times 8.31 times the 365 divided by 0.00202. So mu is equal to the square root of, I didn't do that, hold on. I was going to do that calculation first. 3 times 8.31 times 365 divided by 2.002 is 4504.7. And so when I take the square root of that, mu is 2,122.4 meters per second. So that's the first answer, is this is the average molecular speed, or RMS speed, of hydrogen at 365 degrees Celsius, or Kelvin. Now, how does this compare to the escape velocity? Well, this is in meters per second. This is in kilometers per second. So 2,022.4 meters per second. There's 1,000 meters and 1 kilometer. So it's going to be 2.12 kilometers per second. And that's slower than the escape velocity. So hydrogen will not escape the atmosphere of the moon given that. Okay. All right. Next type of problem. This one wants to know at what temperature does the RMS speed of oxygen equal 475? So we're looking for the temperature, is what we don't know. RMS, which is mu, is equal to what? I have O2, and no, it's not equal to that. It's equal to 475 meters per second in O2. So mu, the formula is mu is equal to the square root of 3 RT over the molar mass. So I need the molar mass, and for oxygen, it is 32.0 grams per mole, 2 times 16. The fact that there is 1,000 grams per 1 kilogram means it's 0.032 kilograms per mole. Temperature is what I'm looking for. Okay, so I have 475 is square root, R is 8.31 of 3 times 8.31 times T divided by the 0.032. Now, this T, or my unknown, is inside the square root. So the very first step I have to do is get rid of the square root. And what do I need to do? How do I do that? I square both sides. So I'm going to have 475 squared is the square root of 3 times 8.31 times T divided by 0.032. And I'm going to square the square root, which means it gets rid of it. So 475 squared is 225,625. And that just got rid, all that did was get rid of the square root sign. So I still have 3 times 8.31 times T divided by 0.032. So I'll multiply both sides by the 0.032. So I have 225,625 times 0.032. I'm going to go ahead and simplify this. 3 times 8.31 is 24.93 T. When I multiply these two together, I get 7220 is equal to 24.93 T. So now I'm going to divide both sides by the 24.93. So 7220 divided by 24.93 is equal to T. And so T then is equal to 289.6. And the units for temperature is K. Okay? And so that is how you do that problem. All right. When we come back, we're going to start on effusion and do an example of effusion.